So if you want to learn more about S.O.L.I.D principles applied in React, but this time with more and more advanced examples. Well, in this video, I'm going to cover up S.O.L.I.D principles advanced examples compared to the previous video where we went through about S.O.L.I.D principles and actually explained S.O.L.I.D principles at the basic level for every single principle. From single responsibility to open close to Liskov substitution, interface segregation, and dependency inversion. So we're going to go through a very advanced examples of how to apply S.O.L.I.D inside of React and how to go from a junior in writing clean code into a senior developer. So before we get started, everyone should know that this video is going to be more of a continuation compared or with previous S.O.L.I.D principles video, the main video. The video, if you go to my channel, Code One in here, you're gonna find like, oh, this is the only right way to write React clean code and S.O.L.I.D. So this is like the main principle video that explains everything at the basic level for beginners and everybody to basically understand what is S.O.L.I.D, how to apply every single principle in React, and explaining pretty much everything. So if you're not familiar with S.O.L.I.D or you don't know how to apply S.O.L.I.D in React, you gotta go ahead and actually watch that video, this particular video first, before you can come back into this video, which is more of an advanced example sort of video. So you can actually continue and watch this video and actually understand everything, because we're not gonna go through into the fundamentals of this video. So we're gonna cover up a lot more of an advanced stuff. So we're gonna be using the same repo that we used before for applying the S.O.L.I.D principles. You're still gonna find all the code inside of there. But this time, instead of we're not going to touch the principles folder, but we actually created a new folder that's named advanced. And inside of that, I'm going to find every single principle in here with advanced example. So let's start with the first principle, which is the single responsibility principle. For a quick definition of the single responsibility, every component should do exactly one thing. So for example, here we got this simple component here, which is edit user profile component, which has like a profile picture where you can click and choose in profile picture. You can update your name, email, and password, and you can click in here, update profile, to actually update and save the changes of your new data or new profile. So this is a little more of an advanced example compared to the previous one, which we covered previously in the previous video, which is a bit simpler compared to this one. So for this one here, we have a simple form, of course. So for this one in here, we have a form, React form in here. We have some file picker in here where you can do some uploading and stuff like that. And basically uses like HTTP or RESTful APIs to update the profile in the database. So if you look into the first component here, which is the bad component, where we haven't applied the single responsibility principle just yet, we've got this component here. It's pretty simple, like edit user profile bad. We have like, oh, we're using use state in here to keep track of the form data, like the name, email, password, and image. We've got another state in here to keep track of the errors. If there are any errors, like, when the user tries to enter the name, maybe you say, oh, we do some validation and actually say, oh, the name is not valid, please choose another name, or like the email or the password in here has to be a strong password, and yada, yada, yada. And here for the handle input change, where basically we just like handle what is the, the current, like whenever an input changes in here, we just go ahead and set the form data like using that state, and we do some validation. So for example, if it's a name, we validate that this name is basically like required. If there's anything wrong, if there's no name, or if it's an empty thing, we just do set errors and set the name. The same thing for the email in here. We do some rejects validation in here. And as well as for the password in here, we'll also use another regular expression to validate how strong the password is. If it's not, we just do, oh, password must meet the criteria. And last but not least in here, we use the handle image change, which is another handler in here to basically just take care of whenever we, upload a new image and actually save it into the state. And we have another handler in here for handling the image change, like whenever it changes, we set it on the state as well. And last but not least, we have this handle submit, where it actually handles, the data we have on our form, and it submits it on that particular API, like localhost, a user update. It does a post for this, and of course, it does some try catch in here to, catch any errors if there are any. And last but not least, in here we have a handle submit, where it handles the submitting to, the updating the data in here, the form data inside of the HTTP in here, our user update. We do a post method, and we use Axios in here, and just save the data and everything. We use this try catch in here to catch any errors if there are any. Okay, that's pretty cool. It looks pretty decent and everything. Now for the JSX, which is the most important part, of course, there's a lot of things going on, like literally a lot of stuff, from like the button in here submitting to a lot of inputs that are being put together. The code isn't really that well readable. You can't actually read it that much. You have to focus a lot on it. There's a lot of input in here that put straight through like row input. They're not encapsulated into like separate components or anything. The form isn't great. There's a lot of low-level handling of the form data and stuff like that. So there's a lot of work to do on this particular component to make it work with the single responsibility principle. So for example here, I can already spot a couple of them, like starting with the image uploader in here or the preview of the image. You see this like form data image. This can be encapsulated into a completely separate component that is only going to be taken and responsible for rendering that preview image and uploading the image into the server. Maybe for example for this one where we have, this is like the input, maybe for each input in here we can create a separate component like a form field or something for every single one of those to render every single input separately. And also, well, like for data handling here, we can handle data differently. We can handle validation differently because validation in here is just super raw and we're not using any library, which we should use for validation because it's super powerful. It's going to make our lives easier, and as well, it's going to make our code super easier and super tied up, as well as like errors in here and the form data. Now, if we go inside of the good one in here, after applying single responsibility principle, I'm gonna find we've done a couple of stuff in here. So let's start with the good one in here. So this is our good user profile component. So we're gonna start in here with the form in here. So for the form in here, we're using a separate library, which I recommend every single time for handling forms in React, which is called the React hook form in here, which is gonna make it 10 times simpler. You're gonna type less code, you're gonna have less gibberish inside of your components, and it's gonna make it super clean and easy to read. Like for example in here, we just do use this use form hook. We provide it with the use form input, which is just an interface of what is the possible, like what are the fields we have, like the typing of the fields. Like we're gonna have a name, email, and a password. And of course, for validation in here, we're going to use S.O.L.I.D, which is another really great library in here that actually takes care of validation. It's very easy to do that as well. It provides a very simple API. Like we can use the Z, we can make sure this is actually a string and a minimum has 1. So if it has, less than 1 in here, we're going to just like go ahead and display the, please enter your email message error in here. For example, if an email, we can just check if it's an email. If it's not, we can display this error as well. Or for the password in here, we can make sure it's a string and it actually adheres to this particular regular expression. Otherwise, we can just display this error. And we can make sure the object is required. As clear as in here, with this simple API, we could completely replace this whole gibberish code in here of like manual validation, which I don't recommend at all. And now the code looks a lot simpler and basically just a single block of code that does everything for us for validation. And this everything is going to be provided to the use form of like React hook in here. It's going to take everything for you and it's going to return to you like a register function, a handle submit, and some state in here to get the errors. Now, the next most important thing we did in here, we went through for our inputs that we had before and actually encapsulated them into a completely separate standalone component, which is called input field. And this input field in here can actually basically render our input for us. So if you open it up, I have it like input field.tsx in here. So this input field in here is pretty simple. So you have like input field, it takes a couple of props in here, like, the label text, the field register in here, and if there are any error in here to basically render the error down here. And of course, this is just a pretty simple. The GSX in here is just rendering an input with the label on top of it, like using the label text and the different props in here passed into the input. Now, the most important part you need to make sure you actually do, this field register in here is actually what needs to be provided from our hook, the use form hook in here from like the third-party library we're using to manage our forms. This will actually gonna be able to go ahead and register the form with the hook or with the library so we can keep track of the state and actually update the value and everything. So we simply just using, the same type that it actually uses from the React hook form in here, use a form register return. We do the field register in here, we just pass it through that one, through props, and here props actually playing a major role for us. And that's actually, a really positive thing for us in as React developers. And that's pretty good. Now, if you go back in here, we're just doing, field register, we do register, and we make sure just register this field with a name, and this field with an email, and the other field with a password. And the same thing goes for the errors. Now, errors in here, we do access errors, name, message, email, and as well as the password in here. So if there is any issues with that, we can just, the errors are going to be popping off. They're going to be put right over here and instead it right over here, and the user can view them easily. And of course, now each component does one thing only because this is an input field. So it does take care of input and validation and displaying the errors and everything. We've got a button in here, which is still doing a single thing as well. So that's good. The other thing what we needed to do as well is the profile picture uploader. So we created a separate component for actually uploading profile picture and previewing it and everything. Now here, it's the same than JSX. It uses the input again. It does image data in here to actually preview the image you're trying to upload. And of course, it does image or upload image to server. So it uploads the image for you. And everything in here again is tied up into its completely separate components that you basically don't need to do anything with it. You don't even need to pass any props to it because everything is encapsulated inside that one. It has its state managed with that one and it works just flawlessly. As well as for submitting the data into the server in here, or just like, calling the API with the actual data we need. So instead of doing it this way, like the raw way, everything is inside of one component, what we need to do is actually go through and actually split that one and create a new file that's called services. So this service file is going to just export a simple function that's called, update user profile, where it takes care of one thing. And actually this is just to make sure we follow single responsibility principle. So it updates user profile, it takes data, it calls the API and updates that one, it returns the response or an error, and that's it. Now we can just go ahead and do await, update user profile with passing the data, and we're done. The second principle is the open-close principle. So the simplest definition of open-close principle, a component should be extended without needing to actually modify the underlying source code. So for example, we've got this simple component or more of like drop-down sort of button where you can click on this button, you can get a list of drop down in here and you can click, for example, new project, new draft, or a new page. And you can click in here and you can just toggle between the menu in here, which is just a normal drop down, right? Now, if we look into the source code in here, it's just a functional component that is a drop down. It takes a bunch of props in here from a title that gets displayed right into this, the button in here, like create or something. The list of items that gets displayed right over here, and whether or not to hide these list items icons. Now, of course, for the rendering part here, we're just using a button to toggle that one, and we just do toggle drop down to change the state. And if the dropdown is open, we just go ahead and render the dropdown where we loop through all the items provided through the props and actually render a dropdown item, which is a standalone item in here that renders every single item as well. And of course, this one takes other props like the icon, name, description, and everything. Now, it may seem this component is pretty good. It adheres to like the single responsibility principle as well. And it adheres somehow to the open-close principle as well, right? All right, cool. So let's go ahead and see how basically the usage of that particular component. So for the usage of the dropdown, we do dropdown, we provide title, we provide the list of items and whether or not to hide icons. And for this one in here, items are going to be an array of objects. Each one is going to define an icon, a name, and a description. And all of those are actually going to be displayed right over here. Now, our code is sort of extendable because now we can play around with the icon. We can like swap the icons, for example, with this. And the other one, we can have like, for example, the same icon where now they are showing the same icon. We can switch and do whatever we want. That at some point is sort of extendable, right? Without actually needing to change or modify the source code. But let's imagine, for example, on the dropdown here, let's say we want to add like in like last thing of the dropdown, like a footer of the dropdown, we add another notion or sort of like a note below over there, say, oh, all changes are saved automatically or something like that. Or maybe we're going to change the order of, how the title of the item and description of the item are displayed or something of that sort, like a very deep extension. Now, when we really apply the OCP or open-close principles into this, it's going to turn our component into this really made up drop-down component, into this really good drop-down component. So in here, it's just a simple function, it's drop-down good. So on this one, as you can clearly see in here, we're actually doing some compound sort of like rendering where each part is exported completely separately. So for example, in here, dropdown, this is like the main container of the dropdown is like exported, all of them exported from the dropdown here, but we do like dropdown, then we access the button, list, item in here. We can render as many items as we want. And of course, because this is basically, we can customize the dropdown however we want. We can like, for example, move the button, below in here. Maybe when I can add something to the footer as we wanted to do before in here, like we can just, this pad in here, we can add it and it's going to be added right below in here, like all projects with auto saved and everything. Now this, what it would look like when you apply OCP. So how we're actually doing that. So if we go inside of the dropdown here, which is the good dropdown, so we're simply in here first creating a context because it's very important to actually share the state between all the components of the dropdown, starting from like the button, the items, the footer, and the container and everything. So here, the main dropdown here just simply holds up the state where we hold up, is dropdown open, or to toggle the dropdown, has another function, and it actually uses the provider, like the context provider we already used, to basically provide the state values so the children can use them. The next thing in here, for example, the button, you can take children, of course, like the button name and everything. And here you can use the use context dropdown provider to basically access to the state we are already providing from the parent dropdown container. And as well, the same thing for the list in here, using the children here to basically render whatever we needed, like the list name in here. And the same thing, we use the use context to access the state in here, and we can do, if it's not open, we can return null for that. Basically the same thing for the item in here. So pretty much every single part of the dropdown is completely independent from the other, and all of them are linked through this really nice context through the provider, and all of them share and can have access to the same state pretty much. And this is actually what it would look like, and it looks pretty nice. Now it's actually, you have like small building blocks of different parts of the actual dropdown, from like the button, the list in here, every single item, and you can utilize those in different places however you want, but the different dropdown items are still having the same source code, literally having the same thing in here. The item is not going to have a different source code, but you can basically customize it however you want. You can provide different props maybe, or maybe a different class name for styling it differently, or maybe you want to put it in a different place. Like you can go ahead and put the item in here right on the top, which of course it doesn't make sense, but it's just like as a quick example and to showcase how that basically works. So using the compound in here and actually applying OCP or open close principle makes the code super clean, easier to read, and of course you can extend it and customize it however you want. For the third principle is Liskov substitution principle. So for the quick definition, subtype components should be easily replaceable with supertype components. So let's say, for example, this simple UI in here where we have a dialog to read the privacy policy. Like for example, we've got here general privacy policy for our application and website, where the user can go through that one, actually read it, whether to deny it and accept and continue. So everything looks pretty good in here, just a simple dialog, simple component and everything. So if you look into the code in here, the bad code, of course. So we got the parent component here, which is the privacy dialog. So this component basically, is the main one that renders the privacy policy, has some JSX in here that renders all the privacy policy, and has some handlers in here, whether to handle basically when the user clicks on accept. So you can basically, provide like a specific ID, for example, of that user or that particular terms of agreement or privacy policy, and actually go ahead and submit it and take it to the home page, or whether to completely deny it from entering the website or using the services. Now let's say later on we needed to basically update our privacy policy where the EU, and you all know the EU regulations, we needed to basically provide a completely separate privacy policy from the rest of the word EU only. So EU in here is going to be a child component of, the main privacy policy dialog, right? So EU in here is basically should follow at some point of how the first one works, or what constraint it should follow and how to basically handle and everything, sort of like independent, right? So this isn't actually following the Liskov substitution principle, because you cannot basically just take this EU privacy dialog component here, completely replace the first parent dialog with it just like that, without ensuring that they both have the same functionality and they both produce and take the same props and they both have the same behavior. So for example, in here, if you notice, like we have on accept in here inside of the EU, it basically takes it set of like a different set of parameters like the name and ID in here, but for our main one, it only takes the ID, it doesn't take the name or something. So we cannot just go ahead and drop this one and expect it to work the same way. You can go ahead and actually just, you can go ahead and just easily swap between, the main privacy policy in here and with the EU privacy policy, but keep in mind that they do not follow the Liskov substitution principle, so you technically cannot ensure the same behavior, so you cannot replace the privacy dialog with the EU privacy dialog that easily. So instead, for the good example in here, what you should do to make sure you actually adhere and work with the Liskov substitution principle is actually you can go ahead and create them like on separate components in here. For example, we got our general privacy policy, which is the main component again, but now they are actually following and adhering and basically tied up with a specific interface, which is called the privacy policy dialog props. So here it's gonna make sure, so every single time we add a new privacy policy, we need to go ahead and use that same interface. That means we need to implement basically the same API, like the same onAccept and onDeny API. And if you notice for this onAccept, it's taking exactly the ID. It doesn't take the name or something. So it makes sure a consistent workflow between all the ones that actually extend from this. So for example, in here, the privacy policy uses that one. So onAccept in here, that means it's gonna only provide the ID in here. Like onAccept is gonna provide the specific ID. If you go for the EU one, the same one in here actually follows the same interface. So like it has to provide onAccept and onDeny. And of course, again, it provides and it uses the same parameters in here. So it provides the same ID only, and it doesn't provide the name or anything other than it actually needs. So it basically provides the same parameters. And of course, inside of our component here, where we use both. So for example in here, the privacy policy dialog in here implements the same onAccept and onDeny. So they basically have, the same things in here, the same handlers and everything, the same parameters in here, because they're basically following the same interface. And if you ever want to replace it and swap it up in here with the EU privacy policy, that's going to be the same thing, because they're both following the same interface. And that means using and following the Liskov substitution principle made our components very easy to replace. For the fourth principle, we got interface segregation principle. So the simple definition for interface segregation principle is components should not depend on props they do not need. It's just as simple as that. So let's say we have this simple example in here where we have like a user dashboard. Let's imagine this is a user dashboard. And for user dashboard, it can do like upload images, videos, and stuff like that. And of course, when those kind of like, jobs are actually finished, they get a notification. So like, for example, in here, project export finished or something with, the email of the user and everything. So if you take, for example, the interface segregation principle, the bad approach. So for instance, if we take the bad approach for this one, let's say for our notification component in here, let's say we have a main component that's called a notification component that basically takes care of rendering both the user and project notification. So it's kind of like rendering two types of notifications inside of the same component. And of course, it takes two props. It takes project or user, and depending on that, so it checks, if it's a project, it only renders the project GSX in here and the project notification. Otherwise, if it's in the user, it renders the GSX for the user. Now, of course, both project and user in here have a specific props in here. For example, the interface of the user, it can take name or email, and for the project in here, it can take name only. Of course, for notification props in here, it can either take any user, which could be an optional prop in here. So user in here have the possibility where it could be undefined. The same thing for the projects in here. Now, for instance, if you quickly look into that component, we can easily know that this component is not adhering to the interface segregation principle, because this component is literally taking two props, two independent props in here, like the user and a project, and both of them could be object, and it only uses one prop on the type. So you can either use project or user. So if you use a project, that means a user is kind of like a not needed prop, right? Or another case, if he uses the user, that means the project's prop in here is not needed at all. So that means it's not actually following the interface segregation principle. And of course, when we try to use that, when we just do like notification, we pass it to user in here, or we can either pass in the project's object in here, and it should work fine. Now, to make our component follow the interface segregation principle in here, we still have the same interfaces and everything, but now instead of having one component that rules them all and actually renders both the notifications for users and projects, like we can simply create two separate components in here. For example, we can name this project notification, that it only takes a project and it only takes the props that it needs, which is the project's prop, and it renders the GSX that it needs, period. And the same thing goes for the user notification here, only takes the user with its own interface, of course, in here, and it renders the GSX he needs. And last but not least in here, we can either render user notification or project notification, depending on what we need. As simple as that, you can follow the interface segregation principle. For the fifth and the last principle is dependency inversion principle. So the simple definition for dependency inversion is component functions or modules should not depend on concrete implementations, but rather depend on common abstraction. Now, to better visualize and actually understand dependency inversion principle, let's say we've got this submit feedback in here, which is like a small dialog form where the user can go in and actually submit a specific feedback by providing his name, the feedback he needs in here on this text area, and click send feedback to send a feedback about our website or application. Now, simply for our feedback form in here, we simply just like, take care of having the state to, save the form data in here, handle the change and everything. And the most important part in here is actually handling submit. So here, handling submit is basically when we click, or when the user goes ahead and click on send feedback to send the feedback and save it on our database. So here, it's basically dependent on concrete implementation where it basically uses, all the details. So like it accesses the, API URL in here right inside of the component, like it prepares the data as well. It does some error handling for that, which is a little too much for our component. And that makes this not adhering to the dependency inversion principle because it actually has a very concrete implementation of the API handling side. And for instance, if you, for example, like let's say, you ship this version 1 of this send feedback form and everything, and after like 6 months or something, you decided to actually change the feedback URL in here where you needed to move from like a third-party service into your own API service with your own database and your completely different properties in here and everything, and all the data are completely different. So you gotta go ahead actually inside of the component again, actually change everything in here, which is going to make it a little harder and it's not going to make it very, very maintainable. But instead of doing it the other way, you can do it in this really good way in here where we have this feedback component, and you can actually use this feedback form and we can actually inject right into a feedback service. And it's clear in here we have 2 versions of the service in here, feedback service version 1 and version 2. And here, feedback form can take it from there using whatever service is provided. And of course, both the services in here have actually the same API. So here you can actually swap between the services very, very easily without even touching the code inside of the feedback. And this will inverse the dependency. So if you go inside of the good feedback form here, it's a normal form. The same thing as we did before, it has basically the same thing, but instead of actually having the concrete implementation of our API handling in here, we're just delegating this into this feedback service, and the feedback service is provided throughout the props. Now the feedback service in here, we have it inside of services, feedback service. So we have created, a separate folder. It's always a good idea to create a separate folder for your services. We called it feedback service, and the feedback service in here, just like a normal class that actually has a constructor. So you can take whatever endpoint. So if you ever wanted to change the endpoint, you can easily do that. And it actually takes a method in here, submit feedbacks. It has the feedback as a string and a name of the the user that is submitting the feedback, and it actually can go ahead and manipulate the data however you want, from like adding IDs, preparing feedback data column in here into a separate function, and most importantly here when it comes to the API, it is actually using a completely separate endpoint that is being fed up from the constructor on top over here. So anytime you can easily access this feedback endpoint submit. Of course, we can easily change this feedback endpoint whenever we need to. So now we can have, like, for example, this endpoint objects in here where it provides feedback endpoint version 1 and version 2, and we can swap between them very easily. And of course, later on, we can create 2 instances of the feedback service in here, each with a different version, and we can easily swap between either version 1 or version 2. And that actually makes it adhere to the dependency inversion principle. So anyway, thank you guys for watching. This has been an advanced examples of the S.O.L.I.D principles applied in React, which is a continuation to the previous video of explaining S.O.L.I.D principles to beginners. So anyway guys, thank you for watching. Hope you guys enjoyed, and catch you all hopefully in the next ones.